Good day, ladies and gentlemen. My name is Dr. Femi Owofadeju of the Department of Wood Products Engineering, University of Ibadan, Nigeria. The title of my presentation is Efficacy of Nigerian Grown Erythrophleum Sauveolens Bark Extracts as Biopreservative against Termite Attack. The demand for wood and wood products in Nigeria and the world over have continued to be on the increase. The global industrial roundwood production from all types of forest for the year 2018 alone was reported to be 2.03 billion cubic meters, according to FAO 2019. When wood is used as construction material, it is generally treated with a chemical preservative to prevent damage by biodeteriorating agents. Some of the primary wood preservatives that are employed are creosote, chromated copper arsenate, CCA, and inorganic arsenicals. However, many preservative chemicals have grave pollution effects on the environment. In addition, the relatively high cost of procurement and low availability often contributed to their low level of adoption in developing countries like Nigeria. Therefore, it is imperative to find wood preservatives that are non-toxic to mammals and environments, that are eco-friendly and cost-effective. It has been observed that the ability of wood and natural plant extractives to protect wood against wood-degrading fungi and insects was one possible approach for developing new wood preservatives. It has also been observed that there are greater potentials in the use of plants and oil extractives as natural preservatives. This study, therefore, assessed the effective use of Erythrophleum Sauveolens oil extracts as natural wood preservative against termites. Erythrophleum Sauveolens is a species of plants found in West and East Africa. The species grow up to 20 meters in height and have a rough and blackish bark. The bark contains a range of alkaloids. In high doses, the bark extract is said to be an extremely strong, rapid-acting cardiac poison in warm-blooded animals, causing shortness of breath, seizures, and cardiac arrest in a few minutes, according to article 2012. The methodology. The bark of Erythrophleum Sauveolens was obtained from logs at a mill in Oyo, Nigeria, latitude 7 degrees 51 north and longitude 3 degrees 55 east. It was identified as the herbarium unit of Forestry Research Institute of Nigeria, FRIN, Ibadan, and thereafter sun-dried for 2 weeks, ground and sieved to size. The wood sample of Ceiba pentandre was obtained at a plant market also in Ibadan, Nigeria, planed and cut to sizes 15 by 25 by 50 millimeters. The weighed wood samples were oven dried at 102 plus or minus 3 degrees Celsius for 24 hours to reduce the moisture content. Extraction process was carried out on 100 grams of ground samples of Erythrophleum Sauveolens in accordance with AOCS 2001 standard, using ethanol as the solvent at 70 degrees Celsius for a period of 16 hours. The oil obtained was concentrated to 100% at 74 degrees Celsius for 3 hours using a Rotary Evaporator. It was digested and analyzed to determine its active ingredients. The extract residue was dried and weighed to determine the percentage yield of the oil. Using the formula, percentage yield equals weight of the sample residue divided by weight of sample before extraction, or multiplied by 100. That is our equation 1. The elemental analysis of the oil extract was carried out in accordance with AOCS 1990 standard, while the concentrations of magnesium, lead, iron, calcium, and copper in the samples were determined through flame photometric analysis. Qualitative phytochemical screening of oil extracts was conducted for saponin, tannin, flavonoid, steroids, terpenoid, emodin, anthocyanins, alkaloids, charcoals, phenols, coumarins, and anthraquinone in accordance with classical methods reported by Majulika 2014 and Williams 2005. The test samples were soaked inside the oil extracts and diluent through cold soaking method in accordance with the method employed by Adedunton in 2015. It was soaked for 24 hours at room temperature at different concentration levels of 0, 25, 50, 75, and 100%, and the percentage absorption determined using the formula absorption rate equals W3 minus W2 over W2 times 100, where W3 is weight of wood after immersion, while W2 is weight of wood after oven dry. The decay test was in accordance with American standard for testing and method D3345-17 standard. The wood samples were exposed to termite attack and visually observed for a period of 6 weeks. Percentage weight losses were calculated using the formula weight loss percent equals T3 minus T4 over T3 times 100. That is equation 3, where T3 equals weight after preservative application and T4 is weight after exposure to termite attack. Now, let's look at our results and discussion. The percentage yield of oil extracts from back of Erythrophleum suaveolens after extraction was found to be 41%, and this signifies high yield from the extraction process. The result is similar to the results reported by Óbuda et al. In 2017, who reported an oil yield of 39% for Erythrophleum ivorens and suggested it to be of moderate high yield. Table 1 shows that copper, which is an active biocide, was present in the oil extract, although not in appreciable quantity. You could see that copper there was 0.005 plus or minus 0.05 parts per million. From table 2, saponin, tannin, steroids, and phenols were found to be present also in the oil extracts. These chemicals are fit as environmentally friendly preservatives when bound with copper and zinc, and they could make non-toxic preservatives suitable for human and other applications, according to Owofadeju and Alawode in 2016. Table 3 shows in quantitative terms these phytochemicals. So you could see in table 3 that the saponin percentage was 13.557. Tannin was 29.706 plus or minus 0.277 milligram GAE per gram. Percentage alkaloid 6.39%, and total phenol 38.71 milligram GAE per gram. Now, results from analysis of variance show that rate of absorption of wood samples at different concentration levels vary. This we can see from table 4. The difference in absorption rates could be due to differences in concentration of the preservative, difference in the wood species and moisture content of wood samples as opined by Ajala et al. In 2012. The higher rate of absorption noted in Ceiba pentandre could also be related to its higher porosity as suggested by Owofadeju et al. In 2009. Analysis of variance for percentage weight loss of wood samples treated with different concentration levels are presented in table 5. It shows that there were significant differences among the treatments at 0.05 probability level. Further tests by Duncan multiple range revealed that 75, 50, 25, and 0% concentration levels are not too significantly different from 100% concentration, but they were different from the control. This is in relation with the work reported by Jala et al. In 2012 about rate of termite attack against test samples treated with Moringa olivera seed oil. The control group had the highest weight loss, which indicated that the level of attack of untreated wood samples by termites is significantly more than that of treated test samples. Wood samples treated with Erythrophleum, Sauveolens, bark oil extract level of 100% had the lowest weight loss, which is an indication that the concentration level was most effective in suppressing the rate of attack of termites. This is similar to the findings of Obumanu et al. In 2005, who also reported increased weight loss with increase in extract concentration level of Lepidogatis albicurides extracts. In conclusion, the oil extracts from bark of Erythrophleum suaveolens had considerable effectiveness against termite attack on Ceiba pentandre, whose samples at varying concentration levels, hence could be used as biological preservative for non-durable wood. The preservative was observed to have no environmental toxicity. Thank you.